Welcome back, NASA Hunch teachers and students. My name is Miss Brittany Koger, and I'm here to walk you through the final investigation station for our Lunar Brick Mold project. All right, so you should have already dove into this project, done the introduction, done the weight and measurement, done the brick making process, and now we're here at the final design phase. All right, this is where we are going to be making a blueprint. We're going to be drawing out our bricks and how we want them to look. And then we're going to take our drawings and we're going to put it on our CAD program, which is Tinkercad. If you do not have Tinkercad yet for your classroom, please, teachers, go get Tinkercad. It is an absolute free website that you can sign up for, and it is wonderful for your students. Trust me, we need these students looking into CAD programs. That is our future. Lots of things are being 3D printed. They're 3D printing houses and food and body parts. I know that sounds so gross and I don't know how all of it goes, but they are 3D printing everything now. So make sure that you're getting into the 3D printing process with your students. I go into our X, Y, Z coordinates and how to measure length, width, height using X, Y, Z on our coordinate plane for Tinkercad. But it's absolutely free. There's websites, there's videos, there's all kinds of things to show you how to use Tinkercad if you have never used it. And like I said, it's free. So even if you don't have printers, you can still get them designing it in Tinkercad. But we're going to make a blueprint on paper first. So you're going to need a couple of things for this station. First, you're going to need a big piece of paper to draw on and sketch out. You're going to need a ruler, and I would go back over measurements real quickly, how there's 16 little marks between 0 and 1, how we read from 0 and go up. And our brick is going to be kind of an odd size, so make sure they're using the ruler correctly, but we're going to be placing that on our table, and we're going to be tracing that in just a minute. So our brick is going to look like this. This is a 1 inch by 5 inch by 1 inch. All right, so it is 1 inch in its width, it is 5 inches in its length, and it is 1 inch in its height. All right. Kind of an odd size, but that is the sizes that NASA gave us. And we're going to be mixing our plastic waste with the regolith of the moon to make this. And then we're going to make a mold in the end that's going to kind of look something like this. Now, notice mine says NASA in there, if you can see that. You get to design yours however you want. When we looked at bricks for our weight and measurement, there was red bricks with holes in them. There were cinder blocks with holes in them. Instead of having a regular hole, could you not have it say NASA? Or could you have it as a star or a planet? Of course you can. This is your brick mold. This is how you want to design it, however you see fit. Put whatever you want in there and make it really cool and unique to you. But we've got to remember when we're making our mold and we're designing our mold, the inside of our mold has to be 1 by 1 by 5. The outside is going to be a little bit bigger, and I went a 1/2 inch bigger on this one. And when you press the material down in there and pull it out, it's going to be shaped just like this mold. And I gave the students Play-Doh when we did that. And we tried to make our own brick in the last station where we made it together, and we tried to mold it with our hands. Didn't work too well, or mine didn't work too well. I don't know about y'all's, but mine did not go too well. All right, so I'm going to show you exactly how we did this with my students. So I'm going to just kind of show you the ruler, and I'm going to show you how we drew this really quick. All right, so over to one side, we are drawing out our brick. So I have a mark that is 5 inches because it is 5 inches in its length, and it is 1 inch wide. All right, now we're going to go off that line, and we're going to go up. And then we're going to connect it up here, up at the top. All right, so 1 inch in width. All right, so you should have a little square or a rectangle drawn out on your paper. Now, over to the side to do the height, unless you want to try to get them to draw a 3D figure, which you can. If you believe that they can do that, you give them a moment and let them try to draw out a three-dimensional, rectangle. If they can do that, go for it. But I just told my students over to the side, we're going to do a 1 inch line, and we're going to put height by it, or tall. You can do either one. 1 inch tall. All right, so just kind of put that over to the side there. So now I have a picture of my brick, and I have a picture of how tall it would be. Now over here, I'm going to do this again, and then I'm going to go around it a 1/2 inch bigger all the way around. You can go an inch bigger if you would like to. This is your brick mold. This is how you want to design it. That's fine, but I'm only going to go a 1/2 inch bigger just because I don't want it to be too big. Remember, we're trying to make it as small as possible, or as lightweight as possible, because it takes $1.2 million per pound of material to go up into space. All right, so all the way around mine, I am putting a 1/2 inch mark. And this might take your students a moment to do this, but you want to get it. And like I said, I went with a 1/2 inch. Now you can go a little bit larger than that. Challenge your students. We want to challenge them. We want to get them thinking, and we really want to get that mind working when it comes to designing and drawing out a blueprint. Now, a blueprint is very important for everything that we do. All of our things that are made, our houses, phones, electronics, they're even made with a blueprint. Nobody just goes out and just makes it. You got to make a blueprint first. So it kind of helps you design how it's going to look in your blueprint. And that's what a blueprint is. It's just a basic outcrop of your shape. All right, so there we go. Boom. It is a 1/2 inch bigger all the way around. So for the sides, it would be 5 1/2 inch, 1 1/2 inch in its width. Now, how tall does it need to be? Are we going to need to make it a 1/2 inch taller, or does it still need to just be 1 inch tall? I'm going to say it's going to still need to be 1 inch, because if we go up to a 1/2 inch, the machine is going to try to put that material in there, and we don't want our bricks to be taller than 1 inch. So we want that to smash down on top of that brick maker. So it's going to look like that. Then you can design in there, like I said, if you want to do stars, maybe you want to put NASA in there. Make this your design. I'm going to put some stars, and then I'm going to put a crescent moon in the middle. Don't laugh at my crescent moon. It kind of looks like Pac-Man. But have fun with this. Go into an art lesson and let them just kind of design their own little brick mold. They can make as many of these as they would like. Have fun with it. And then take these measurements and try to design the same thing on Tinkercad. Like I said, if you don't know how to get to Tinkercad, there is a link in here that tells you exactly how to sign up for that. If you have another CAD program, do it in that CAD program. But just getting them thinking in those coordinate planes and getting them thinking in the 3D printing process is very important. But a blueprint is important for everything that we do. And let them have fun with that brick mold. Do whatever you want and design it however you want. Put as many different things in there as possible. Just kind of go off on a little art lesson and have fun with it. Have fun with this station, guys. Take as much time, design as many as you can, draw out blueprints, because blueprints are very important for everything that we do. You want a blueprint. We got to know our sizes, our weights, our measurements, and all of that. We got to take all of that into consideration before we build something to go into space. So just have fun with this station, and I can't wait to see you guys at the next station. Bye, guys.